Hi, my name is Brian, and I'm a front-end web developer at Livefront. Have you ever seen one of those websites with a cool landing page with eye-catching 3D effects? Or maybe played a 3D game that runs in the browser? Have you ever wondered how to build something like that? Well, if you're a React developer, I'm here to tell you that you can, using tools you're already familiar with. Today, I'll show you how to implement a simple interactive 3D scene for the web. Before we dive into the code, though, I first want to introduce you to the underlying tools we'll use to build the demo. First is Three.js. Three.js is a JavaScript library that simplifies building 3D content for the web. It provides high-level objects like shapes, lights, and cameras to build a scene, as well as ways to interact with those objects through code. Three.js on its own is well suited for vanilla JavaScript applications. But the second tool we'll talk about is a companion library called React 3 Fiber. React 3 Fiber brings together the power of Three.js with the familiar patterns and ecosystem of React. Let's take a look. Here I've got an empty React project already set up and running. Let's start building our 3D scene. To start, we need to install the dependencies. I'm using npm, though you can use whatever package manager you like. To start adding 3D content, I first need to add a canvas. But this isn't just any old HTML canvas. The React 3 Fiber canvas is our entry point into Three.js. Rather than putting normal HTML components inside this canvas, we add React 3 Fiber components, which turn into Three.js objects behind the scenes. This means we have a whole new set of primitives to work with. You can look through the documentation to see what kinds of components are provided out of the box. Speaking of primitives, let's add something to our 3D scene. We'll walk through some of the more common components. To start, a mesh is Three.js's way of defining objects that we'll see in our world. However, a mesh doesn't show anything by itself. To give our mesh a shape, so to speak, we need to add some geometry to it. Geometry defines where the surface of our object should be. Here, I'm adding a sphere. There are a number of other built-in geometries, such as box, cylinder, and plane, but you can also import your own 3D models from programs like Blender. I'll make it blue. But wait a second, it was supposed to be blue. Why did it turn black? The reason is that, much like the real world, we need light to see materials like the standard material here. Let's add some lights to see. Since the light isn't part of the object itself, but rather part of the world, I'll add a new light to our canvas. I'll use a point light, which sends virtual light rays in all directions outward from a point. And then I'll set the brightness with the intensity prop. However, our sphere is still all black. That's because by default, both our mesh and light are placed in the center of our 3D world. So the light is basically inside of this solid sphere, meaning the light isn't shining on our material. To fix that, let's move where the light is placed. We can set the position prop on the light component to move it within our 3D scene. The position is defined in world units, which are different than something like pixels. You can think of it more like a meter in the real world. I'll put our light 2 units to the right, 2 units up, and 2.5 units towards us. Now we can see our blue material and the 3D shape of our sphere. I can even add more lights, like this 3-point light setup, for more visual interest. And because this is still React code, I can even break these lights into a separate custom component. Similarly, since these are React components, we can easily add event handlers. Let's say we want to change the color of the sphere when we hover the mouse over it. We can add pointer over and out event handlers to detect when the mouse moves onto and off of the sphere. To keep track of which state we're in, we can do that with our old friend useState. I'm going with useState, but you can also use whatever React state management suits your needs. Then, we set the state based on the mouse. Lastly, we can use this state to conditionally set the color of our material. Now that it's all hooked up, we can test it out. This was just a brief introduction to the very basics of what you can do using Three.js and React. To recap, we added an object to our 3D world, made it look more realistic with the material and lighting, and made it interactive using familiar event handling patterns. There's a whole lot more you can do, including camera control, animation, physics, VR, AR, and even more. I hope you're as excited about the possibilities of 3D on the web as I am. So, what will you make? Thanks for watching.